Our universe is a vast and mysterious place. It's filled with billions of galaxies, each containing billions of stars. It's a place of incredible beauty and complexity. But have you ever stopped to wonder where it all came from? How did this universe with all its wonders come to be? The universe as we know it began around 13.8 billion years ago. Before that, there was nothing. No space, no time, no matter. Everything we see around us, from the smallest atom to the largest galaxy, was once compressed into an infinitely small point. This point, known as a singularity, contained all the energy and potential of the universe. Then, something extraordinary happened. The singularity began to expand. This wasn't an explosion in the traditional sense, like a bomb going off. Instead, it was the expansion of space itself. Imagine a tiny balloon suddenly inflating to an enormous size. That's closer to what happened during the Big Bang. This expansion, this moment of creation, is what we call the Big Bang. It marks the beginning of everything we know and understand. It is the birth of our universe. The Big Bang wasn't a chaotic event. It followed the laws of physics, laws that we are still uncovering today. In the first fraction of a second, the universe was an unimaginably hot and dense soup of energy. As the universe expanded, it cooled. This cooling allowed for the formation of the first particles, the building blocks of everything we see around us. The universe was well on its way to becoming the cosmos we know today. As the universe continued its rapid expansion and cooling, a crucial transition took place. Around 380,000 years after the Big Bang, the universe had cooled enough for electrons to be captured by the atomic nuclei. This capture was a defining moment, marking the formation of the first atoms, primarily hydrogen and helium. With the formation of atoms, the universe underwent a dramatic change. Before this point, the universe was opaque, like a thick fog. Light couldn't travel freely because it was constantly being scattered by the free electrons. But with electrons now bound to atoms, the universe became transparent. This first light, released when the universe was just 380,000 years old, still exists today. Known as the cosmic microwave background radiation, it permeates the universe as a faint afterglow of the Big Bang. Studying this radiation provides us with invaluable insights into the early universe. The formation of atoms from a sea of particles was a pivotal step in the universe's evolution. It set the stage for the next major chapter, the emergence of the first stars and galaxies from the darkness. After the formation of the first atoms, the universe entered a period known as the Dark Ages. It was a time before stars, when the universe was filled with vast clouds of hydrogen and helium. Gravity, the architect of the cosmos, began to work its magic on these clouds. Over millions of years, gravity pulled these clouds together, compressing them into denser and denser regions. As these regions collapsed under their own weight, the temperature and pressure at their cores soared. Finally, the pressure and temperature became so intense that nuclear fusion ignited in the hearts of these collapsing clouds. These were no ordinary stars. They were colossal giants, hundreds of times more massive than our sun. These first stars blazed with a ferocity that we can scarcely imagine, flooding the surrounding universe with intense ultraviolet radiation. They were the engines of cosmic evolution. The birth of these first stars marked the end of the Dark Ages. Their light pierced the darkness, illuminating the cosmos and setting in motion a chain of events that would lead to the formation of galaxies and ultimately to us. Section 5, Galactic Genesis. Islands in the cosmic ocean. The first stars were not solitary wanderers. They were born in clusters, bound by gravity within vast clouds of hydrogen and helium. These clusters became the building blocks of galaxies. They merged and collided, forming the grand spirals and shapes we observe today. Our Milky Way, with its spiral arms and billions of stars, is a testament to this process. Massive stars exploded as supernovae, seeding space with heavier elements. The universe, once dark, now ablaze with billions of galaxies, each a cosmic island. Section 6. Our cosmic cradle. The birth of the solar system. Within the Milky Way galaxy, about 4.6 billion years ago, a vast cloud of gas and dust began to collapse. As the solar nebula collapsed, it began to spin faster and faster, like a figure skater pulling in their arms. This spinning motion flattened the cloud into a disk, with most of the mass concentrated at the center. Eventually, the temperature and pressure at the center of the disk reached a critical point, igniting nuclear fusion. Our sun, a yellow dwarf star, was born. Section 7. Seeds of life, from stardust to Earth. In the chaotic early solar system, planetesimals collided and coalesced, some growing larger and more massive. Closer to the Sun, rocky planets like Mercury, Venus, Earth, and Mars formed. Farther out, gas giants like Jupiter and Saturn accreted massive atmospheres. The early Earth was bombarded by asteroids and comets. These impacts delivered water and organic molecules, essential for life. A Mars-sized object collided with young Earth. The debris coalesced to form our moon. The moon stabilized Earth's axial tilt, creating seasons. Section 8. The living planet, life finds a foothold. About 3.8 billion years ago, in the primordial oceans that covered the young Earth, something extraordinary happened. Simple organic molecules, perhaps delivered by comets or synthesized in volcanic vents, assembled themselves into more complex structures. These structures, in turn, began to self-replicate, marking the dawn of life on our planet. The first life forms were single-celled organisms, similar to bacteria. These early microbes thrived in the harsh conditions of the early Earth, evolving and adapting to their environment. Over billions of years, life diversified and complexified. Photosynthesis evolved, releasing oxygen into the atmosphere and paving the way for the evolution of oxygen-breathing organisms. From the first single-celled organisms to the incredible diversity of life we see today, the story of life on Earth is a testament to the power of evolution. Life has transformed our planet, shaping the atmosphere, sculpting the land, and creating the very conditions that make Earth habitable. The emergence of life on our planet is a profound event, a testament to the universe's ability to create complexity and beauty from the simplest of ingredients. Section 9. A universe expanding, the ever-growing cosmos. In the early 20th century, astronomers made a groundbreaking discovery. The universe wasn't static, it was expanding. Distant galaxies were moving away from us, and the farther away they were, the faster they were receding. This observation, supported by numerous lines of evidence, revolutionized our understanding of the cosmos. The expansion of the universe isn't like the expansion of an explosion, it's the stretching of space itself. Imagine a loaf of raisin bread dough rising in the oven. As the dough expands, the raisins, representing galaxies, move farther apart from each other. The expansion of the universe has profound implications for its fate. Will the universe continue to expand forever, becoming colder and more diffuse? Or will gravity eventually halt the expansion, causing the universe to collapse in on itself in a big crunch? The answer to this question depends on the amount of matter and energy in the universe, factors that cosmologists are still diligently trying to measure and understand. Section 10. The Fate of the Universe. A look into the future. The fate of the universe is a question that has intrigued scientists and philosophers for centuries. Will the universe continue to expand forever, or will it eventually collapse in on itself? The answer depends on the balance between the expansion of the universe and the pull of gravity. If the expansion of the universe is strong enough to overcome gravity, then the universe will continue to expand indefinitely. This is known as the Big Freeze scenario, where the universe becomes increasingly cold, dark, and diffuse, as galaxies move farther apart and stars eventually burn out. However, if gravity is strong enough, it could eventually halt the expansion of the universe and cause it to contract. This contraction would lead to a big crunch, where the universe collapses back in on itself, potentially leading to another Big Bang. The fate of the universe is still uncertain, but scientists are actively researching and gathering data to better understand the forces at play. The answer to this fundamental question will have profound implications for our understanding of the cosmos and our place within it. Section 11. The Universe and Us, Our Place in the Cosmos. From the Big Bang to the present day, the universe has been on an incredible journey of evolution and change. We, as humans, are a product of this cosmic evolution, our very existence intertwined with the birth and death of stars, the formation of galaxies, and the intricate dance of matter and energy. As we continue to explore the universe and unravel its mysteries, we gain a deeper appreciation for its vastness and complexity. We are but a small part of something much greater than ourselves, a cosmic tapestry woven from stardust and shaped by the laws of physics. Our journey of cosmic discovery is far from over. With each new observation, each new discovery, we gain a deeper understanding of our place in the universe and the interconnectedness of all things. The universe is not merely a backdrop to our existence, it is an integral part of who we are. We are stardust, and we are home to a universe of wonders.